Hello my dear learners, I am Dr. Pawan Kumar Shukla and I am taking the classes of antenna and wave propagation. I am professor in Rajkumar Goyal Institute of Technology and till now I have covered the basic introduction of antenna. Now I will discuss a very new concept in antenna theory as antenna array. In my today's lecture, I will brief the introduction of antenna array, why these antenna arrays are important in the antenna theory and how these are utilized for getting a better directivity and a better polarization from the system of antenna array. So, we are starting the topic antenna array. Actually, in a single element of antenna, we have seen that the radiation pattern as the most important and fundamental thing of any antenna, and generally the major concern for utilizing any antenna in a communication system is to get better and greater directivity in the desired direction. Basically, this antenna array concept is directly related to that requirement for the different communication system, especially in the case of point to point communications, where we need a very specific directivity, some very crucial directional characteristics, and to get those parameters, to get those characteristics for the specified antenna, we use a system, radiating system, which is called as antenna array. So, as you can see here, the radiation pattern of a single element is relatively wide in the sense of its beam width. When the beam width is wide, it means its directional characteristics are not so much useful for the antenna purpose, and each element provides low value of directivity. Obviously, if beam width is wide, then the directivity or gain will also be not very much fruitful. In many of the applications, it is necessary to design antennas with higher directional characteristics, as I have explained very clearly that in most of the cases in specific communication applications, it is desired that the antenna or any antenna system which is used for the directional characteristic for getting the signals in a better way, we need better directivity, we need better gain for the antenna or antenna system. We can only increase the directivity or gain of the antenna by enlarging its physical aperture, by enlarging its electrical size, but it is very difficult to increase the electrical size of the antenna, because nowadays all the systems are being compacted. So, obviously, the antenna system should also be in the same format, in the same size, where all the requirements, all the other accessories, equipments and systems of communication systems are being utilized. So, we cannot increase the physical size or electrical size of the antenna system. So, what we can do here? Higher directivity is the basic requirement in point to point communications, likewise in the radars or space applications. Enlarging the dimensions of single element often leads to more directive characteristics. Another way to enlarge the dimensions of the antenna without increasing the size of the individual elements is to form an assembly of radiating elements in an electrical and geometrical configurations. Basically, this is the basic theme of any array system. When we use multiple elements, generally these all elements are of the same kind, and these same kind of elements are spaced properly, phased properly, and this complete radiating system is used for getting better directional characteristics, for getting better directivity. One thing more which is very important in the establishment of an antenna array system, that all the elements must be oriented properly. The orientation of all the elements must be same. They cannot be abruptly placed in the plane, in either of the plane where this antenna array system is used. Thus, finally, we can define the antenna array system as the radiating system of multiple elements. Here we consider element as a single antenna. So, this is a combination of large number of multiple antennas which are placed properly, which are spaced properly, which are phased properly, and which are oriented similarly to get better directional characteristics for the specific applications. So, this is the overall definition of antenna array. I hope you you must be able to understand the concept of antenna array. This is a very special case of antenna array system, although nowadays antenna array system is a very vast and very dynamic topic, where the concepts of MIMO system and other kinds of array patterns are available. In most of the software systems, we generally utilize the antenna array system, and we use many things to obtain the structure and to design this antenna array system. But whatever I am going to deliver, that is the basic things for the antenna array system, so that you can understand the concept of antenna array and how the antenna arrays are useful in the antenna theory, why these are considered to be a very relevant topic for the further studies. So, uniform linear array is a very basic kind of antenna array system, where the elements are spaced, all the elements which are of same kind are spaced in equal intervals. The antenna array is said to be linear. The linear antenna array is defined as the antenna array where all the elements are equally spaced along a straight line, and this linear antenna array system is said as uniform linear array when all the elements are fed with a current of equal magnitude with progressive uniform phase shift along the line. This is a very important thing to understand, especially in the case of antenna array system, where we know that all the elements in an array system are excited with its own current. It means every element in the antenna array system is having its own current of its own amplitude and its own phase. So, what are the conditions for the relatively those currents which are being given to the elements of an array system? So, the uniform progressive phase shift means all the elements in an antenna array system are excited with the currents having same magnitude, but the phase of each and individual element of the antenna array system must be in a proper format, that is called uniform progressive phase shift, and that uniform progressive phase shift can be defined as, suppose element number 1 in antenna array system is excited with a current I1 and this I1 is equal to I naught sin omega t. In that same array system, the element number 2 is excited with the current I2. This I2 can be defined as I2 is equal to I naught sin omega t plus theta, means the magnitude I naught must be same for all the elements, but the phase shift, the uniform progressive phase shift, it means the phase difference between the first and second element is equal to theta, and if the element number 3 is excited with the current of I3, then this I3 must be equal to I naught sin omega t plus twice of theta. This is called uniform progressive phase shift, uniform progressive, 0, theta, 2 theta, thrice of theta, 4 theta, like this. This is the uniform progressive phase shift. So, this is the basic concept, and 5 controls are used to shape the overall pattern of the antenna array system, and these 5 controls are geometrical configuration of the overall array system, relative displacement between the elements, excitation amplitude of the individual element, excitation phase of the individual elements, relative pattern of the individual elements. These are the 5 factors which will control the overall radiation pattern of an antenna array system, because the basic requirement for designing any antenna array system is to improve the radiation pattern of the individual element, and we can get the better performance in the case of radiation pattern by getting sharper beam width measure lobes. This is the basic requirement of any antenna array system. What are the types of antenna array system? These are the basic types of antenna array system where we can classify the different configurations and the different orientations of the elements in a plane. Like this, broadside array, it is usually referred to as BSA, end fire array, EFA, collinear array and parasitic array. These all are basic kind of array system or array configuration. The first and the most basic form of the antenna array system is called as broadside array. Broadside array and its configuration is shown in the figure, and it is shown that in a plane the elements are placed and a number of identical antennas are placed parallel to each other along the straight lines, and the direction of maximum radiation is always perpendicular to the plane consisting of the elements. This is the most important point of broadside array. It should also always be referred that the direction of maximum radiation is the perpendicular direction where these elements are placed. Perpendicular direction for what? Perpendicular to the plane where these elements are placed. And as you see in this diagram, the direction of maximum radiation is like this, means the elements are placed in this plane and the direction of maximum radiation is along upward and downward. So, as we know that if the direction of maximum radiation is upward and downward both, then the resultant radiation pattern will be bidirectional radiation pattern. All the individual antennas are spaced equally along the axis of antenna array as uniform linear array. All the elements are fed with currents with equal magnitude and same phase. This is also a very important property of the broadside array. All the elements are excited with the currents having same amplitude and same phase. It is not the case of uniform linear array, it is the case of same, means all the elements are having no phase difference. All the elements are excited with the current as I1 is equal to I naught sin omega 2, I2 omega t, I2 is equal to I naught sin omega t, I3 is equal to I naught sin omega t. एम्पलीट्यूड भी सेम है और फेज भी सेम है. As the maximum radiation is directed in broadside direction, means perpendicular to the line of axis of the array, the radiation pattern for the broadside array is bidirectional. Simple. When the direction of maximum radiation is upward direction and downward direction along a plane, then the radiation pattern will be bidirectional. This straight line is perpendicular to the axis of individual antenna and it is known as the axis of the antenna array. Thus, each element is perpendicular to the axis of antenna array. Thus, broadside array can be defined as the array in which the antennas are having their maximum radiation in the direction perpendicular to the axis of array and plane containing the elements of array. So, this direction of maximum radiation is perpendicular to both the lines. First one, array axis means where the elements are placed, array axis, and the plane at which all these elements are put together. Next is end fire array. End fire array is very similar to the broadside array because the placing of the elements are almost similar, but the difference is the excitation of the elements with the currents. It is different, and it is different in the way that the currents which are excited, the currents which are given to the individual elements in the magnitude wise they are same, but they all are opposite in phase, means the adjacent elements are excited with the currents which are having the currents having the phase which are out of phase, means 180 degree phase difference. And because of this property, the elements which are placed in an end fire array, they are having their direction of maximum radiation along the array axis. So, the end fire array, number of the identical antennas are spaced equally along a line, as I have already told you that this is also a case of linear array, but when we talk about the uniform linear array, then the phase difference between the elements is 180 degree. All the antennas are fed individually with currents of equal magnitudes, but their phases vary progressively along the line to get entire arrangement unidirectional finally, and maximum radiation along the axis of array as shown in the shown figure, that the direction of maximum radiation is along the array axis. And one thing which is more important, that is the radiation pattern of the end fire array case is unidirectional. Unidirectional means the major lobe exists only in one single direction, but it can also be converted into a bidirectional radiation pattern where the phasing and the spacing can be adjusted to get a bidirectional radiation pattern, we will discuss later. So, the end fire array can be defined as an array with direction of maximum radiation coincides with the direction of array axis to get unidirectional radiation pattern. Next is collinear array. Collinear array is also a very simple type of antenna array system which is used mostly in the case of broadcasting antennas, where the requirement of a radiation pattern is not so much directional, because when we talk about the transmitting antenna, it is very similar to the pattern of an isotropic radiator, and when an isotropic radiator's radiation pattern is concerned, it is uniformly distributed in all the directions. So, simply we can say that collinear array can be configured in two directions, either it is normal axis or it is horizontal axis. You can see here in the diagram that both the kind of collinear arrays are prescribed here, and the elements are placed in a collinear array along a straight line or a perpendicular line. So, as the name indicates, in the collinear array the antennas are arranged coaxially, the antennas are arranged end to end simply along a single line as shown. The individual elements in the collinear array are fed with currents equal in magnitude and phase. The condition is similar to the broadside array. Simply we can see here that some of the properties are very important in the collinear array, especially in the case of broadcasting array. Last one is parasitic array. It is very important because most of the very directional antennas are based on this theory of parasitic array. Parasitic array means parasites, parasites are there, parasites means परजीवी जो दूसरों की जिंदगी से अपनी जिंदगी लेते हैं, means the elements which are taking the energy from the living elements. In the case of parasitic array where minimum 3 elements are required, one element is live, which is known as driven element, live element, which is having its own excitation, but all the other elements are having no any current. They are feeling excited with the currents of that live element or that driven element. So, simply we can say that it is a combination of minimum 3 kinds of elements. One element is known as driven element, which is having its own current, its own energy, and the other 2 elements are known as directors and reflectors. The combination of these 3 elements is known as the simplest form of a parasitic array, and which is also known as Yagi-Uda array, also known as Yagi antenna, and this Yagi antenna is shown here in this diagram. If you remember, this is a very simple kind of antenna which has been used in the previous days for the television receiver. In our homes, generally we use these antennas for getting the television signals from the transmitting end. So, the very common example of this parasitic array is a half wave dipole antenna in the form of Yagi-Uda array. So, simply we can say that all these 4 types of antenna array system are very basic kind of configuration of antenna array, and all these can be extended to get greater directivity, better performance in its directional characteristics. So, it was simply an introduction of antenna array system. In my next lecture, I will discuss some more important things related to antenna array. So, thank you very much for watching this video. Thank you.